Welcome to the training module on the MPLAB starter kit for PIC18F MCUs. This training module will discuss the hardware features of the PIC18F starter kit, including the features available on the PIC18F46J50 family devices, as well as the demos that come with the kit. The starter kit consists of a software installation disk, the starter kit board, a USB Mini B cable to connect the starter kit to a PC, and a micro SD memory card with pre-compiled demo applications. Before connecting the starter kit to the PC, install the starter kit software by inserting the CD into your PC and following the instructions. The installer program will install the MPLAB IDE, a student version of the MPLAB C18C compiler, the bootloader, the demo applications, and the starter kit documentation. Let's take a look at the starter kit board. Note the white rectangle on the bottom of the board. The circuitry inside of this rectangle is an in-circuit debugger. This circuitry allows you to debug an application on the starter kit without the need for an external debugger. The circuitry outside of the white rectangle is its demonstration application. At the heart of this application is a PIC18F46J50. This is a 44-pin member of the PIC18F J series flash microcontroller family with USB capability. The MCU features 64 KB of flash program memory and 3776 bytes of RAM. The 4-element keypad is an integral part of the board's top layer. The application responds to capacitive changes induced by direct contact with the user by monitoring each of the touchpad's elements with the microcontroller's integrated CTMU module. A 128 by 64 pixel monochrome organic LED array provides a wide range of graphics and alphanumeric display options. A 3-axis acceleration sensor measures the acceleration on all 3 axes and can be used in different applications to determine the tilt of the board, which can also be used, for example, to control the movement of the cursor in a USB mouse demo. A switch can be used at any time within the demo applications to load the bootloader menu. Micro SD memory card provides storage space for pre-compiled application files. The bootloader can load applications from the micro SD card and program them to the microprocessor's flash memory. The potentiometer provides an analog input to the microcontroller for certain demo applications. The Mini B USB receptacle provides system power and bidirectional communication between the host PC and the starter kit. The PIC18F microcontrollers have many features and peripherals that make them powerful, versatile platforms for embedded projects. Let's discuss the features that are available in the PIC18F46J50 family devices. The Parallel Master Port, or PnP, is a parallel 8-bit I/O module specifically designed to communicate with a wide variety of parallel devices such as communication peripherals, LCDs, external memory devices, and microcontrollers. The real-time clock and calendar module is a 100-year clock and calendar with automatic leap year detection. It runs off a 32.768 kHz input from the secondary oscillator and is optimized for low power usage and battery-powered applications. The Universal Serial Bus module contains the analog and digital components to provide a USB 2.0 full-speed and low-speed device implementation with a minimum of external components. The Charge Time Measurement Unit is a flexible analog module that provides accurate differential time management between pulse sources as well as asynchronous pulse generation. The CTMU allows an application like the starter kit to utilize capacitive touch sensors for user input. 2 MSSP modules can be configured for either I2C or SPIKE communication with other peripheral or microcontroller devices. 2 enhanced capture compare PWM modules contain a 16-bit register which can operate as a 16-bit capture register, a 16-bit compare register, or a PWM master or slave duty cycle register. The 10-bit analog to digital converter allows conversion of an analog input signal to a corresponding 10-bit digital number with auto acquisition capability and self-calibration. 2 enhanced USART modules with auto wake-up or start bit that supports RS-485, RS-232, LIN, or PIC18F46J50 A major challenge in general-purpose devices is providing the largest possible set of peripheral features while minimizing the conflict of features on I/O pins. Peripheral pin select also allows peripherals to overlay each other. In addition, peripheral pin select allows multiple pins to be used for a single output function, increasing the drive strength. In this demo, the peripheral pin select is used to multiplex the SPI communication lines with the PnP communication lines, allowing for flexible usage of the I/O pins available on the part. Let's discuss how to use the PIC18F starter kit. Once the starter kit software is installed, connect the provided USB cable to any available USB port on a PC or power hub, then to the starter kit at the mini-B receptacle on the application side of the board. The PC USB connection provides communication and power to the board. A micro SD memory card used to store the demo applications may be connected to the starter kit at any time. If the cable is connected correctly, the green power or D3 light is lit. The output LED will display microchip PIC18F starter kit startup menu, and the application processor will wait for the menu button to be pressed in order to load the micro SD bootloader. The PIC18F starter kit is built around a micro SD card bootloader. The bootloader allows multiple demos to be loaded into SD card and loaded into the microcontroller when they are selected from the bootloader menu. The flash program memory of microchip's PIC18F46J50 device is readable, writable, and erasable during normal operation over the entire VDD range. This feature gives the user the ability to perform bootloading operations. To demonstrate this feature, the MPLAB starter kit for PIC18 comes with pre-programmed micro SD card bootloader that gives the ability to load, program, and run the PIC18 applications from a micro SD card. The micro SD bootloader accepts user inputs from the capacitive touch sensor buttons and scroll bar and uses the output LED display for user outputs. The micro SD bootloader uses substantial parts of the microchip memory disk drive file system to read files and folders from a micro SD memory card. When the board is powered, a welcome screen is displayed and the board waits for the menu button to be pressed in order to load the bootloader. If the counter reaches 0, the last program application will be loaded. A micro SD memory card can be inserted at any time. When it will be detected by the micro SD bootloader, the MDD file system will be initialized and the file structure will be displayed on the output LED. Please note that only folders and hex files will be displayed. The user can press the up and down buttons to select a specific file or folder. If the accept button is pressed when a folder is selected, the micro SD bootloader will display on the output LED the contents of that specific folder. To return one level up, the user can either press the cancel button or can use the accept button when the folder is selected. If the accept button is pressed when a hex file is selected, the micro SD bootloader will prompt the user for a confirmation to load the file from the micro SD memory card and to program it onto the microcontroller's flash memory. After this operation is finished, the user may choose to execute that application or to remain in the bootloader. If the cancel button is pressed in the root directory, the micro SD bootloader will exit and the last program application will be executed. There are several pre-compiled demos that come loaded on the micro SD card ready for testing on the PIC18F starter kit. These include a mouse demo using the accelerometer, a joystick demo again using the accelerometer, a custom human interface device application that allows custom application data to be sent over the bus, a CDC demo that allows the board to appear like a serial port to the computer, and a mass storage demo that allows the board to appear like a drive on the computer. In this demo, the board will act like a USB mouse using the accelerometer as a tilt sensor. Hold the board flat relative to the ground for no movement. If you have difficulty finding the mouse cursor on the screen, or if you keep losing it, please make sure that the board is flat relative to the ground. Tilt the board to move the cursor. Press the L button to left-click and the R button to right-click. Hold the menu button to return to the demo menu and to load a different application. In this demo, the board will act like a USB joystick. Tilt the board to move the joystick on the X or Y axis. Use the scroll bar to move it on the Z axis. Use the potentiometer to rotate around the Z axis. Touch the L and R capacitive pads to control the first and second buttons. A test program is included in the application folder for the joystick demo that allows testing of the joystick features. The game controllers option from the Microsoft Windows control panel can also be used to show the joystick behavior. Hold the menu button to return to the demo menu and to load a different application. In this demo, the board will act like a USB custom HID device. Connect the board to the host computer and run the HID PnP Demo.exe file provided on the CD-ROM disk. The PC application is reading the raw data from the capacitive pads, acceleration sensor, and potentiometer. To demonstrate the bidirectional communication, the MTouch Calibrate button on the user interface is triggering the calibration routine of the MTouch library on the PIC18 starter kit. Hold the menu button to return to the demo menu and to load a different application. In this demo, the board will act like a USB communication device. When this demo application is connected for the first time to a host computer, it will ask for an INF file. In this case, point to the INF file provided on the CD-ROM in the CDC Demo folder. After the complete enumeration, the board will appear like a serial port on the host computer and will start to send the raw data from the acceleration sensor. Use your preferred hyperterminal software and connect to the COM port created by the board to see the data. Hold the menu button to return to the demo menu and to load a different application. In this demo, the board will act like a USB mass storage device. Insert a microSD memory card and connect the board to the host computer. Files can be read, deleted, and manipulated like any other drive on the computer. Hold the menu button to return to the demo menu and to load a different application.